And we're back. Okay, what I was going to say about the z-tables and what makes this sometimes a little bit complicated is oftentimes the z-table distribution is divided into left, and right proportions. In other words, okay, so if this green little curvy thing represents where all our data would be, okay, and this would be the mean, the right-sided z-table is going to measure the probability that something would occur in here versus the left one would be probability that something occurs in here. Okay, so what I'm basically getting at is because the table is split into two portions, when you're looking at 90% confidence and we're having to deal most commonly with a right-sided table, what we want to do is we want to split that 90% confidence in half because we're only dealing with half of the actual table. So 90 divided by 2 is going to be equal to, or 0.90, right, because it's 90% confidence, is going to be equal to 0.45. Okay, so what that means is that this is what we're looking for with a right-sided z-table, which again is most commonly given to you when you have to look these things up. So if we pull up a z-table, and I did this up here, so this is a, oops, we scroll up a little bit, the right side z-table, we're looking for a confidence of 0.45. So we can kind of look at this. Let's see, where would this be? That's confidence of 43, 40. Okay, here we are. Right between this one and that one, okay? Because that's 4495 and 4505, a little bit over, a little bit under, whatever. You just pick one of them. You can just abbreviate it. So that corresponds with 1.64, 1.65. I'll split the difference. We'll say 1.645. But hopefully you kind of see the idea there. All right. So that means a 90% confidence interval, z-value, that corresponds with the right side would be a value of 1.645. Okay? So we just plug this in. 1.645 for our z-value. And our margin of error was supposed to be within 4%, so that's 0.04, all of that squared. And boom. That's all we're looking for. Now it's just calculator work, just figuring out what would that be. Okay? And I did work it out. Let's see if I can find it. What did I get here? I ended up getting, if you plug all the numbers in and solve this, you should get something like this. N should approximately be equal to 425.39, which, again, if we're sampling real people, we can't have a fraction of them, so I guess we would just bump that up to 426. So what we figured out here was that if we want to be 90% confident that how many of the people think the president controls the price of gasoline, we would need to sample at least 426 people. Okay? Now, then, that's part A. So check, check. That's what we would need. Then it says, find the minimum sample needed using a prior study that found that 22% of respondents said they think the president can control the price of gasoline. Well, it's exactly the same equation, but now, unlike in the first case, we did not know what any of the proportions were at the beginning, so therefore we just assumed 0.5. 50% said yes, 50% said no. Now we know that 22% said yes, and therefore we can plug that in for the p-hat thing. So it's just going to be, don't worry, I'm not going to work this all out, but it would just be 0.22, right? That would be the proportion of people that said they think the president controls the price of gasoline, which he does not, just by the way. 1 minus 0.22, and then that times, well, we still have the same z-value, because it's still, we're looking for 90% confidence, so it's going to be 1.645, and that over square root, or the error rate, which again is still the same, that's 0.04, and that's squared. And, there you have it. And if you plug all that in your, actually yellow is probably not the best choice. If you plug that in your calculator, you should end up with something like N is approximately equal to, what did I get? I got 291.99. So, again, we can't have a fraction of people, so we would say that that would be 292. So, what this means is that if you, basically that you would need to have, if you had no idea of what anybody thought, what percentage of people thought about the president's controlling gasoline, you would need to have 426 people to make a reasonably accurate, within 90% confidence of what the population thinks. However, if you do know a little bit, if you do know that there's 22% said yes, then your sample size is a little bit smaller. You only need to have 292 people. But again, the major formula is this thing right here. All you have to do with this is just plug in the numbers that you're given. Again, if they do not tell you what the initial percentage is, you just plug in 0.5 for p hat and solve for there. Okay, but if they tell you that you need 22%, well then, you plug in, like we have here, 22%, and then, of course, flip side. So if 22% said yes, 1 minus 22% said no, that would be, what is that, 78%, right? Whatever. And then work from there. Okay, that's all that is. Good. Let's move on to the next problem. Oh, okay. I'm going to just do this very quickly. The problem that you gave me, I didn't write it all out again, but I have same as above, but with the accuracy to 5%. So again, our formula is going to be, what is it? The number of people that we need is going to be equal to the percentage of people that said yes minus or times the percentage of people that said no, and all of that times whatever our z-value is over the error rate, and then that is supposed to be squared. Okay, so again, plugging things in. If our accuracy is 5%, it's the same deal. We don't know the initial p-value, so we plug in 0.5. And then that times, again, it's the same 90% confidence interval, so that was 1.645 over, now our error rate is a little bit different. Our error rate is 0.05, right, because we want to have 5% accuracy. Okay, so if you do all that, you plug your numbers in, you should end up with something like, n should approximately, oops, oh gosh, what is that? N is approximately equal to 204.19. Okay, which then simplifies to, we've got to have it 205, right, because we can't have a fraction of a person. So that would be the minimum amount that you would need if your accuracy rate, or your error rate was 5%. Okay, and then it says, do it again if 25% agreed. Well, hopefully, again, this should be somewhat redundant, but all we would do, same equation, n is equal to, now we know the percentage that said yes, that's 0.25, 1 minus 0.25, which, of course, is 75%, times the z-value, which still is 645, because we want 90% confidence, and then the error rate is 0.5, and square that. That's it, times. There you go. And then if you plug that in your calculator and solve it, you should end up with something like, oh, actually, you know what, I messed up. I did this backwards. Hold on a second. This one, the second one in pink, that's the one that's approximately equal to 205. Sorry, I misread my numbers. If you plug these numbers in, you actually you don't get 204. You end up with something like, what did I have here? 272.25. So that would be equal to 273. Okay, so anyway, point is, what you would need, the minimum sample you need for part A is going to be 273 people, and then the minimum sample you need for part B is going to be 205. And again, it's just plugging in numbers into that equation. Okay? Now, I think last one. Here we go. Last one. Now, this time we have a table, and we're asked to construct a confidence interval for the proportion from the adults from the East who think traffic congestion is a serious problem. So here's what we know. We know 35% of the people sampled from the East, think traffic is a serious problem, and we know that the sample size was 400. Okay? So basically, here's our equation. It's very similar to the previous one, but here's what we got to do. The proportion, the real proportion of the population, or p hat, it's going to be plus or minus the z-score times the square root, and I'll leave it as a creative exercise if you want to kind of compare this one with the previous equation. You can see some similarities, but again, if just for notes, this is all you need to jot down, and then just plug numbers in. Okay? So it's going to be percentage that said yes times the percentage that said no, divided by the number of people sampled, take the square root, plug in a z-value, and then multiply, add or plus or minus whatever it is that we started with as the sample percentage. Okay, so let's just plug some numbers in. Here we go. Hold on a second. There we go. So we know initially p hat, or the percentage of people that said yes, congestion is a serious problem, is 35%. So that's 0.35 plus or minus. Okay, now z-score again. We want to be 95% certain. Okay, so again, remember, right tail, left tail kind of thing. 95% divided by 2, what is that? It's 47.5. So that should be something like that. So this is the value that we're looking for on our right-tailed Z distribution thing. So let's look at this. Hopefully that made sense. So we look for 47.5. Where is this? 42, 46. Right there. So that's 1.9. I'm pretty sure it's 96. Yeah, it's 1.96 is the Z value there. Pull this back up. Okay, so we know our Z value is 1.96. Okay, so now we just plug everything in. Here we go. 1.96 times the square root of, okay, percentage of people that said yes times the percentage of people that said no, so that'd be 0.35 said yes. Well, the percentage that said no, or 1 minus 0.35, is going to be 0.65, right? And then that divided by the number of people sampled, which was 400. And there we have it. And you just solve for this, right? You can plug this in your calculator. I did it ahead of time, and what I ended up with was something like all of the, hold on, I'm changing colors again. All of this works out to be approximately, where is it? There it is, 0.0467. Again, kind of rounded it off. I guess we could approximate that. I don't know how precise we have to be. Let's just leave it at that. I was going to round up to 5%, but whatever. So approximately we could be up or down roughly 4.7%. Okay? So that would mean our 95% confidence interval would mean we could be wrong by as much as 4.7%. So if we subtract 0.35 minus 4.7, I don't know, whatever that is, that's going to be what? 0.303? Yeah, 30.3%. And then we could be off by, we could have minimized it a little bit, so we would just simply add 4.7 to this, and that would give us, what is it? 0.397. And that would be our confidence interval. That's it. Again, the equation here is all that you need. Just plug in the numbers, and there you have it. Hopefully that was helpful.